In the previous lecture, we discussed principle of superposition. I hope you know what is principle of superposition. Let me remind you principle of superposition. What was principle of superposition? If we have an nth order differential equation and y1 of x, y2 of x, so on, yn of x are the solutions of an nth order ODE, then the principle of superposition is that the linear combination of these n solutions. How do we write the linear combination? C1 y1 of x plus C2 y2 of x plus so on plus Cn yn of x. If we call this another function of y of x, then the new function y of x will also be the solution of the given differential equation. This is what principle of superposition tells us. So this function will also be the solution of the given nth order ODE. So in short, this was the principle of superposition. Now we are going to discuss linearly independent and dependent solutions. Linearly independent or dependent solutions, or you can say functions, because these n solutions are in fact functions, different functions. Now if we have n functions, different functions. For example, let we have f1 of x, f2 of x, so on, fn of x. These are n functions. Then these functions will be called linearly dependent if they must be defined on some common interval. Let these are n functions defined on some interval I. Then these functions will be called linearly dependent if there exist constants C1, C2, so on, Cn, such that C1 f1 of x plus C2 f2 of x plus so on plus Cn fn of x. If we put this linear combination equal to 0, and solve this, if we get all the constants, if there exist constants, this and this, you can include here not all 0, such that this equation is satisfied if there exist constants C1, C2, so on, Cn, not all 0, such that this equation has been satisfied. Then we say that the functions f1, f2, fn, then the functions f1, f2, so on fn are called linearly dependent. This is basically the definition of linearly dependent functions. Now, let's have an example of this definition. Example. For example, if we have let f of f1 of x is x, f2 of x is what? X squared, and f3 of x is 4x minus x 3x squared. 3x squared. We are given three functions, and we need to know whether these functions are linearly dependent or not. If these functions are not linearly dependent, we say that they are linearly independent functions. How do we check? We say that there are constants C1, C2, C3. These constants are basically real constants. They belong to R. So we consider C1 f1 of x plus C2 f2 of x plus C3 f3 of x. And we put it equal to 0, this equation. We consider this equation, and then from this equation, we have to show that these constants C1, C2, C3, they are not all 0. At least one of these constants should not be 0 to know that whether these functions are linearly dependent. Now, what is C1? F1 of x is what? X plus C2, x squared plus C3, 4x minus 3x squared. We put it equal to 0. We start by writing this equation, and then we solve it. We try to find the constants C1, C2, C3, the values of the constant which satisfy this equation. And how can we solve this equation? So basically, these functions are polynomial functions. We can compare the coefficients. For example, x or यहाँ पे x है, you can take this common x and you can write C1 plus 4C3 plus इसके बाद x square का कोफिशिएंट क्या है? C2 plus x square common ले लें, and you get C1 minus 3C3 equal to 0. Now, comparing the coefficients on both sides, you can write the right hand side in this way: 0x plus 0x square. Now, comparing the coefficients on both sides.
ये x square into C2 minus 3C3 नहीं होगा?
X square into
C2 minus 3C3.
यहाँ पे yes, C2 ही होगा. Thank you very much. So comparing the coefficients on both sides, this must be C1 plus C3 is equal to 0, and then another C2 minus 3 C3 is equal to 0. We obtained these two equations, and we can solve these two equations simultaneously in order to find the constant C1, C2, and C3. But we have three unknowns here in two equations. Can we obtain C1 and C2 and C3 uniquely? You can solve this linear system. This is basically a linear homogeneous linear system we can convert it, or we can write an augmented matrix as you did in your linear algebra course. I hope you know how to solve homogeneous linear systems. 1, 0, 4, 0, and 0, 1, -3, 0, and then you have nothing. You have this augmented matrix. Now, we can reduce this augmented matrix into echelon or reduced echelon form, and then we can solve it. But we have two equations and three unknowns. So one variable, you have to put it free variable. I hope you remember linear algebra. How do you solve the linear system of this kind? So we have to put a free variable here. For example, we put C3 as a free variable. Okay. अगर आप let me do it here. तो आपके पास C1 किसके इक्वल आएगा? C1 would be -4C3 and C2 would be 3C3. Yeah. So C3 is free variable. Okay. It means C3 can have any zero or non-zero value. So the value of C3 is arbitrary. अगर value of C3 को हम choose करें, for example 1, तो C2 क्या आ जाएगा? 3, and C1 क्या आएगा? -4. So these are the values of the constants which satisfy this equation. So C1 की value क्या है हमारे पास यहाँ पे? -4. So -4x plus C2 की value 3x square plus C3 की value 1. So 4x minus 3x square. So ये आपके पास is this expression is equal to 0? Yes. क्योंकि आपके पास यहाँ पे ये और ये कैंसिल हो गया, ये और ये कैंसिल हो गया. So we get 0 is equal to 0 with non-zero constants C1, C2, and C3. This implies that the given functions, therefore, the functions f1 of x जो कि given था, what was it? X, f2 of x, x square, and f3 of x is 4x minus 3x square, I think, this one. These functions are linearly dependent functions. These functions are linearly independent functions, and the set of these functions, f1 of x, f2 of x, and f3 of x, this set is linearly independent set.
इसे डिपेंडेंट नहीं होना चाहिए.
सॉरी, डिपेंडेंट. यार ये डिपेंडेंट ही लिखा हुआ, आप देखें और से. So therefore, these functions are linearly dependent functions, and the set of these three functions is basically linearly dependent set. If at least one of the constants of these constants in this equation or in this definition जो कि हमने लिखी थी यहाँ पे, so we have n functions. We consider this equation with the unknown constants C1, C2, so on, Cn. If at least one of these constants is not zero, is not identically zero, then we say that these functions are linearly dependent. Otherwise, if all these constants, after solving this equation, if all the constants C1, C2, so on, Cn sorry, they are identically zero, then we say that these functions are linearly independent functions. I hope you get it. इस तरह की you have already, I think, discussed this concept in linear algebra course, MATH210. So if you have any question, you can ask me. Let's have another example of linearly independent functions. For example, if I change the functions to be,
इसके अंदर जो हमारा फ्री वेरिएबल है इसे हम 1 क्यों अज्यूम करते हैं, हम इसको कोई कांस्टेंट रियल कांस्टेंट क्यों नहीं अज्यूम करते हैं?
you can, again, C3 is arbitrary. You can take it any value from R. Okay? Because initially we assume that C1, C2, C3, they are constants, they belongs to R. Now after solving it, यहाँ पे हमारे पास we get a homogeneous linear system, and we have two equations and three unknowns. So one variable must be arbitrary. Okay? We have to choose it arbitrary from the real numbers. We can choose any value of this constant. आप zero लेंगे तो सारे zero आ जाएंगे. अगर C3, if you choose Z3 0, तो ये सारे के सारे क्या हो जाएंगे? Zero हो जाएंगे. ठीक है? But all these constants should be identically zero. ये नहीं होना चाहिए कि constants जो हैं वो किसी दूसरे constant पे depend करें. ठीक है? यहाँ पे C1 C3 पे depend कर रहा है, C2 भी C3 पे depend कर रहा है, और C3 क्या है? Arbitrary है. ठीक है? Arbitrary में C3 की कोई भी value ले सकते हैं. So all these constants should identically be zero if you want that these functions are linearly independent. If at least one of the constants is not basically zero, or it is free variable, or it can have any arbitrary value, then we say that this constant is not identically zero. In that case, the functions are linearly dependent functions. Because देखिए ये वाला फंक्शन जो है, ये वाला डिपेंडेंट फंक्शंस क्या होते हैं? If one function can be written as a linear combination of other function, ठीक है? अगर आपके पास एक फंक्शन है f of f1 of x, या यही एग्जांपल आप देख लें, अगर x है, दूसरी एग्जांपल f2 of x आपके पास 6x है. Are these functions linearly independent? No, they are not independent. Second function depends on the first function. How can we write the second function? Second function is basically 6 times first function. They depend on each other. But if I write here x square, 6x square, now f2 cannot be written as a linear combination of f1. So in that case, they are linearly independent functions. They do not depend on each other. Similarly, in this example जो कि अभी हमने देखी है, इसमें अगर आप देखें, f3 is a function which can be written as a linear combination of other two functions. Can I write f3 as f3 of x? If you look at this function 4x, it is basically 4f1. 4f1 of x here plus minus 3 times f2 of x plus minus 3 times f2 of x. Now f3 depends on f1 and f2. So f3 is a linear combination of f1 and f2. So f3 is not independent function. Okay? If at least one of the function can be written as a linear combination of other functions, other remaining functions, in that case also we say that these functions are not independent functions. They are not linearly independent functions. They are linearly dependent functions. ठीक है? Now इसको अगर आप देखें, इसको दूसरी साइड पे ले जाएं, तो what is this? 4f1 plus minus 3f2 minus plus minus 1 f3. This is equal to 0. ये आप इसको C1 ले लें, इसको आप C2 ले लें, इसको आप C3 ले लें. ठीक है? So C1 is 4, C2 is minus 3, and C3 is minus 1. So these constants are not zero. Even this equation is basically satisfied, this thing is equal to zero. If these constants are not identically zero, then we say that these functions are linearly dependent.
Thank you, sir.
I hope you get it. Let me have another example in which we can prove that the functions are linearly independent. For example, this one, 1 plus x, 1 plus x, and x squared. These are three functions. We need to prove that these functions are linearly independent. What we do, we write again the same, we start with the same equation, c1 f1 of x plus c2 f2 of x plus c3 and f3 of x here. And we put it equal to 0. And we try to find the values of c1, c2, c3. So now if we try to compare the coefficients, what we can write c1 plus c2 x plus c3 x squared equal to 0 plus 0x plus 0x squared. This is how we solve a polynomial equation with unknown constants. How do we write? Here we have a polynomial with unknown constants. You can have here 1, okay, x squared. So we can write 0 into 1, 0 into x, 0 into x squared. So now comparing coefficients of same powers of x on both sides, we can write on comparing same powers of x, how can we write? C1 is equal to 0, C1 plus C2 is equal to 0, and C3 is equal to 0. What do we get here? We get a homogeneous linear system, which can be written in 1, 0, 0, in an augmented form. Again, 1, 1, 0, 0, and then 0, 0, 1, 0. Okay. After solving this augmented matrix, I hope you know how to solve it. It's straightforward here. We will definitely get C1 0, C2 0, and C3 0. They are all identically 0. They do not depend on each other. None of the constants C1, C2, C3 is arbitrary. Okay? All are identically 0. This means the functions f1, f2, and f3, or the set of functions f1, f2, f3 is linearly independent. Is linearly independent set. I hope you know how to do it now. If you have any question, you can ask me. If you have any question, you can ask me. Otherwise, now basically, if the functions are kind of polynomial functions, then it is basically easy to find whether they are linearly independent or not. If the functions are basically, they are not polynomials. For example, if we have functions 1, cosine of x, and sine of x. These are three functions. How would you know that these functions are linearly independent or not? It would be difficult to solve that kind of that kind of equation and find the values of the constants, unknown constants. Now, so it is basically necessary to define some other way of finding whether the given set of functions is linearly independent or not. So for that, we define Wronskian. Wronskian. Now, what is the Wronskian? Wronskian basically helps us to find whether the given set of functions is linearly independent or not. And how do we define Wronskian if we have, for example, let f1 of x, f2 of x, sorry, f2 of x, and so on, fn of x. They're all functions of x defined on some same interval I. Okay. Now, how do we define the Wronskian? Wronskian is defined basically Wronskian of, you can say f1, f2, so on, fn. Wronskian of these n functions is defined in this way. It's basically determinant of f1, f2, so on, fn, basically f1 of x, f2 of x, and so on, fn of x. And then in the second line, we define the derivatives, f1 dash, f2 dash, so on, fn dash, and so on. We define in third row f1 double dash, f2 double dash. आप इसको इस तरह लिख लें so that you remember it. यहाँ पे third row में what we have, f1 double dash, f2 double dash means second derivative of these functions, fn double dash, and so on. In the last line, what do you define here? Fn minus 1th derivative of first function, f2 n minus 1th derivative, and so on, fn of fn minus 1th derivative. So this is how we define Wronskian of any particular given functions, n functions. Now these functions will be then the set of functions, then the set of these functions f1, f2, so on, fn is linearly independent if Wronskian, which is what, f1, f2, so on, fn, Wronskian is not equal to 0 for all x belongs to that particular interval I. So in order to find these functions are linearly independent, what do? We find the Wronskian of these functions, and if the Wronskian is non-zero, for every x belongs to I. This is very important. You need to remember it. For all x belongs to I. Otherwise, if Wronskian is 0 for at least one value of x belongs to I, then we say that these functions are linearly dependent functions. ठीक है? आप कह सकते हैं if Wronskian is 0 for some, या आप कह सकते हैं at least one, for some x belongs to I, then the set f1, fn, the set is linearly dependent set. I hope you get it. Now let's apply this definition on the examples which we already did for linear independence and dependence. Or you can take this example as well. Now it is easy to find whether these functions are linearly independent or not. So let's find whether the given functions, these trigonometric functions, are linearly independent or not. So if we have these three functions, You have f1 of x is 1, f2 of x is what? It is cosine of x, and f3 of x is sine of x. So we find the Wronskian of f1, f2, and f3 is equal to what? We write the functions first in the first row without the derivative or zero derivative. 1 cos x sine x. Okay. And then derivative of these functions, first derivative 0 cos का derivative minus sine का derivative cos of x. And then again 0 का derivative 0 sine का derivative cos of x, cos का derivative again minus sine of x. Now you solve this determinant. इसको determinant को how can we solve? I hope you know, you have already done this in your linear algebra course. ठीक है, इसको रहने दें. यहाँ पे कॉलम 1 से आप इसको अगर एक्सपेंड करें या रो 1 से, then how can we write? It's basically 1 times determinant of this submatrix minus sine of x cos of x minus cos of x, and then minus sine of x. This, after solving this, we multiply these two, sine square x, this one, and then minus, we multiply these two, and it becomes plus cos square of x. Now, sine square x plus cos square x is what? It is 1. Whatever the value of x is here, we put here. Whatever the value of x, we put here. So all these three functions are basically defined on what? Defined on R, means set of real numbers. So you can see that the Wronskian is not equal to 0, is not equal to 0, whatever the value of x we choose here. Or you can say for all values of x, Wronskian is not 0. If Wronskian is not 0 for all values of x, then what do we say? We said that these three functions are linearly independent functions. I hope you get it. If you have any question, you can ask me. If you have any question regarding the linearly independent or dependent functions, you can ask me that question. Okay, now there is a criterion for linearly independent solutions. Now we come back to the solutions of the differential equation. There is a question in the chat window. Let me see that question. How does the Wronskian tell us they are independent? This is just the method, but what makes them independent in this case? So I didn't get the determinant part. So basically, it's a Wronskian. Wronskian, it's a basically theorem proved in the book. I can show you the proof. If the functions are linearly independent, we can prove that this determinant, which we call it's Wronskian, is always non-zero. Okay? It's a theorem. Okay? Again, if the Wronskian is 0 for at least some one value of x, then the functions are linearly dependent. Okay? Wronskian is basically proved in a similar method by starting with this criteria. Okay? With this definition. ठीक है, अगर हम इस definition से start करें, ये आपके पास functions हैं, ठीक है, आपके पास कितने unknowns हैं? n unknown हैं. n unknown है, then you
सर कोई
must
नहीं
have
नजर आ रहा.
the, oh sorry, let me change the board. Okay, where did this Wronskian come from? अब आपके पास, अगर आपके पास n functions हैं, आपके पास you have one equations in n unknown, c1 c2 so on cn. From the linear algebra you know that if you have one equation and n unknowns, you cannot find the values of these unknown constants c1 c2 so on cn. Okay? In order to find these n unknown constants uniquely, you must have n equations. आपके पास n unknowns find करने के लिए n equations होने चाहिए. ठीक है, n equations कैसे आएंगी? आपके पास ये एक इक्वेशन है, ठीक है, दूसरी इक्वेशन क्या होगी? आप इस सारी इक्वेशन का डेरिवेटिव ले लें, कांस्टेंट्स तो बाहर आ जाएंगे. ठीक है, व्हाट डू यू गेट? f1 डैश, f2 डैश, fn डैश. ठीक है, तीसरी इक्वेशन के लिए आप एक और डेरिवेटिव ले लें इस पूरी इक्वेशन का, आपके पास क्या आ जाएगा? f1 डबल डैश, f2 डबल डैश, fn डबल डैश एंड सो ऑन. कितने इक्वेशंस चाहिए आपके पास? n इक्वेशंस चाहिए. तो n इक्वेशंस के लिए आपको हाउ मेनी डेरिवेटिव्स यू हैव टू टेक हियर? n minus 1, बिकॉज जीरो डेरिवेटिव वाली इक्वेशन भी है. जब n minus 1 डेरिवेटिव्स लेंगे तो आपके पास n इक्वेशंस आ जाएंगी. ठीक है, फंक्शंस वही होंगे. बेसिकली न्यू इक्वेशंस कहां से आएंगी? हम फंक्शंस के डेरिवेटिव लेते जा रहे हैं. अब आपके पास n इक्वेशंस और n अननोन्स हैं. ठीक है, फॉर एग्जाम्पल आप यू लिखते हैं c1 f1 प्लस c2 f2 प्लस सो ऑन प्लस cn fn. सेकेंड इक्वेशन में c1 f1 डैश प्लस c2 f2 डैश प्लस सो ऑन प्लस cn fn डैश इक्वल टू जीरो एंड सो ऑन एंड सो ऑन एंड सो ऑन. ठीक है, यहां पे क्या आ जाएगा? c1 f1 n minus 1 dash plus c2 f2 n minus 1 dash plus so on plus cn fn n minus 1 dash. ठीक है, अब यहां से ये आपके पास एक homogeneous linear system आ गया. Now how can we write this thing basically in terms of matrices? इसको matrices की फॉर्म में कैसे लिख सकते हैं हम? f1 f2 gg बेटा fn कैमरा सॉरी हाँ, यहाँ पे आपके पास पहली इक्वेशन वही है, आपने उसके डेरिवेटिव्स ले लिए. फर्स्ट डेरिवेटिव लिया, आपके पास ये इक्वेशन आ जाएगी. n minus 1 डेरिवेटिव लेंगे तो आपके पास ये आ जाएगा. नाउ यू गेट द होमोजेनियस लीनियर सिस्टम इन n इक्वेशंस विद n अननोन. इस होमोजेनियस लीनियर सिस्टम को अगर आप कोएफिशिएंट मैट्रिक्स की फॉर्म में लिखें तो क्या होगा? f1 f2 fn, फिर f1 डैश f2 डैश सो ऑन fn डैश एंड सो ऑन एंड सो ऑन एंड सो ऑन f1 n minus 1th dash so on fn n minus 1th dash. This is coefficient matrix, and then the coefficient vector is unknown vector is c1 c2 so on cn is equal to what? 0 0 so on 0. ये आ जाएगा. Now this is a homogeneous linear system. ठीक है, homogeneous linear system का जो नॉन ट्रिवियल सॉल्यूशन होगा वो कब होगा, या ट्रिवियल सॉल्यूशन कब होगा? अगर आपके पास a c इक्वल टू 0 है तो इसका ट्रिवियल सॉल्यूशन कब होगा? मींस व्हेन डू वी गेट c इज इक्वल टू 0? ये c वेक्टर है. बेसिकली c वेक्टर इज व्हाट? दिस वेक्टर. अगर हम इसको c वेक्टर कह दें एंड दिस वी कॉल a मैट्रिक्स. a ना कहें, यहां पे w कह दें. बेसिकली चलें a कह दें. ठीक है, अब ये होमोजेनस लीनियर सिस्टम है, इसका ट्रिवियल सॉल्यूशन कब होगा? लीनियर अलजेब्रा आपने पढ़ा हुआ है. हु वाज आस्किंग द क्वेश्चन? यू टेल मी.
फिर जब जीरो होगा.
क्या जीरो होगा?
इस सारे का सॉल्यूशन.
जीरो सॉल्यूशन कब होगा?
जब सारे कांस्टेंट्स को ऐड करेंगे और वो जीरो होगा.
ऐड करेंगे तो जीरो होगा. ये आपके पास एक होमोजेनस लीनियर सिस्टम है. c जीरो कब होगा? मींस आपके पास ट्रिवियल सॉल्यूशन कब आएगा? c जीरो होने का मतलब क्या है कि ऑल दीज c1 c2 so on cn विल बी जीरो. ये कब होंगे? अंडर व्हाट कंडीशन?
इसका सॉल्यूशन एग्जिस्ट करना चाहिए. यानी उसका डिटर्मिनेंट जो नॉन जीरो होगा,
किसका?
जो हमारा मैट्रिक्स मल्टीप्लाई हो रहा है वेक्टर के
कोएफिशिएंट मैट्रिक्स
साथ।
must be non-singular. The coefficient matrix must be invertible. इन्वर्टिबल होने का मतलब क्या है कि इसका इन्वर्स एग्जिस्ट करना चाहिए. इसका इन्वर्स एग्जिस्ट करेगा अगर, तो इसको हम दूसरी साइड पे ले जाएंगे. ठीक है. फ्रॉम हियर यू कैन से दैट C इज इक्वल टू A इनवर्स टाइम्स जीरो. ठीक है. A इनवर्स टाइम्स जीरो इज जीरो. मींस आपके पास सारे कांस्टेंट्स की वैल्यूज C1 C2 सो ऑन Cn की सारी वैल्यूज जीरो होंगी. अगर सारे कांस्टेंट्स की वैल्यू आइडेंटिकली जीरो हो तो ये फंक्शंस क्या होंगे? लीनियरली इंडिपेंडेंट होंगे. अच्छा, अगर ए इन्वर्टिबल है तो इसका मतलब क्या होगा? ए का डिटर्मिनेंट क्या होना चाहिए? नॉन जीरो होना चाहिए. ठीक है. हम कहेंगे डिटर्मिनेंट ऑफ ए शुड नॉट बी जीरो, और डिटर्मिनेंट ऑफ ए को हमने क्या कह दिया? रॉन्स्कियन. ठीक है. नाउ हाउ डू वी डिफाइन रॉन्स्कियन हियर? इन दिस वे. रॉन्स्कियन क्या है? बेसिकली ये जो कोएफिशिएंट मैट्रिक्स है इसका डिटर्मिनेंट, इसको हमने रॉन्स्कियन कह दिया. और अकॉर्डिंग टू दैट डेफिनेशन, यहां पे हमने जब कहा था कि ये रॉन्स्कियन क्या है, डिटर्मिनेंट ऑफ f1 f2 f3, ये पहले हमने लिखे, फर्स्ट डेरिवेटिव एंड सेकंड डेरिवेटिव. ये इसका अगर डिटर्मिनेंट नॉन जीरो है तो इसका मतलब क्या होगा कि in this homogeneous linear system, the values of all these constants must be zero. If the values of these constants is zero, then what do we say? We say that the set of functions is linearly independent. I hope
Thank
you
you,
get
sir.
it. Where do we get this Wronskian? And why we are saying that the determinant of this Wronskian should not be zero for all values of x, for the functions to be linearly independent. और दूसरा क्वेश्चन क्या था? What was the other question? Determinant कैसे आपको फाइंड करते हैं? हसन तनवीर, I didn't get the determinant part. Determinant कैसे फाइंड करते हैं यार? ये लीनियर अलजेब्रा में आपने पढ़ा होगा. Please revise that thing. Determinant कैसे फाइंड करते हैं? Discuss it with the Furqan. I think he will explain you. अगर कोई प्रॉब्लम हुआ तो you can discuss this thing with me in the next lecture. ठीक है? I don't have much time to. So हाँ, linearly independent and dependent हमने दोनों discuss किए. Now we are going to discuss fundamental set of solutions. We have seen here that these functions are linearly independent if the Wronskian is non-zero. तो अब हम देखते हैं कि fundamental set of solutions. Set of solutions of an nth order ODE. Fundamental set of solutions आप यही देख लेना. चलें. Let y1, y2, so on, yn of x is of let this be a set of linearly independent solutions of an nth order ODE. ठीक है. If this set of solution is linearly independent, it is called fundamental set of solutions. ठीक है. Or you can say that any set solutions, any set of n solutions of nth order ODE will be called fundamental set of solution if this set is linearly independent set. ठीक है, अगर आपके पास n solutions हैं, वो linearly independent हैं, तो हम कहेंगे कि वो fundamental set of solutions हैं. ठीक है. Now the next definition is general solution. General solution. किसी भी nth order ODE का nth order ODE आप कह सकते हो यहाँ पे this is valid basically nth order homogeneous nth order homogeneous ODE. This is valid fundamental set or the linear independent set. Linearly independent functions, they are basically for the homogeneous nth order ODE. ठीक है, इसी तरह जनरल सॉल्यूशन ऑफ nth ऑर्डर आप कह सकते हैं यहाँ पे homogeneous ODE. ठीक है, नॉन होमोजेनस के लिए ये वैलिड नहीं होगा. ठीक है, जनरल सॉल्यूशन अगर इफ आपके पास y1 y2 so on yn is a fundamental set, the fundamental set of solutions of some nth order ODE of an nth order ODE, then the function which is y of x, c1 y1 of x plus c2 y2 of x plus so on plus cn yn of x. This, which is what? It's a linear combination of the functions which forms the fundamental set. Okay, is called general solution of that ODE. Okay. So how do we write general solution? किसी भी differential equation का general solution लिखने के लिए if that differential equation is nth order homogeneous differential equation, then we must have a fundamental set which contains n linearly independent solutions of that differential equation. If this set exists, then we can write the general solution of that nth order homogeneous differential equation by writing the linear combination of those linearly independent functions. Okay. This is how we can write the general solution. For example, let's discuss these concepts with the help of an example. Meanwhile, if you have any question, you can ask me. I'm gonna erase this board. अगर आपका कोई question है, तो you can ask me. Okay, then let's discuss these things with the help of an example. हाँ, ये है. Example. We are given this differential equation y double dash minus y dash minus 12y equal to 0. And we are given also y1 of x is e raised power minus 3x and y2 of x is e raised power 4x. And these functions are defined on R. R means minus infinity to plus infinity. So these are two functions. We need to prove that these two functions forms a fundamental set of solutions, and then we have to write the general solution of the given differential equation. First, we need to do what? Step 1, prove or
sir,
verify.
camera move करना.
Sorry. I need to move the camera. This one. Yeah. This one. So we consider this example. The differential equation is y double dash minus y dash minus 12y is equal to 0. And we are given two functions, y1 and y2. And they are defined on the whole real line. We need to prove that these two functions forms the fundamental set of solutions of this differential equation. And then we have to write the general solution. Okay. पहले हमने क्या करना है? Prove that these two functions or verify, prove कर दें आप, prove that the set what y1 y2 forms a fundamental set of solutions. Okay. Second, write the general solution. General solution of the given ODE, ODE1, आप इसको 1 कह देना. पहले पार्ट में फंडामेंटल सेट प्रूफ करना है आपने. फंडामेंटल सेट प्रूफ करने के लिए व्हाट वी हैव टू डू, we have to prove that these two functions are linearly independent. And how can we prove that these two functions are linearly independent? We have to find their Wronskian of y1, y2. Wronskian of y1, y2 is what? It is basically the functions e to the power 3x, e to the power 4x, and then their derivatives. Derivative of this is e to the power this minus 3 times e to the power minus 3x. Or यहाँ पे 4 times e to the power 4x. So we need to solve this determinant now. When we multiply these two, what do we get? 4 times e to the power x, because minus 3x or 4x क्या हो जाएंगे? X. And then we multiply these two, minus plus 3 times e to the power again x. So we solve it. It is 7 e to the power x. Now, would this be 0 for some value of x? Anyone? Huzafa? Or any other? Daniel?
सर नहीं, मेरा नहीं ख्याल से.
0 नहीं होगा किसी भी वैल्यू के लिए?
यस सर, नहीं होगा.
क्यों नहीं होगा?
सर क्योंकि e raised to the power x तो मेरा नहीं ख्याल से 0 होती है.
हाँ, is never 0 for any value of x. E raised by x is never 0 for all x belongs to R. Okay. It means Wronskian is never 0 for any value of x. Therefore, the set of functions y1, y2 forms fundamental set of solutions. ठीक. अब अगर ये fundamental set of solutions बनाता है, then how can we write the general solution? The general solution of the given differential equation is what? Now the general solution is y of x, and how do we write c1 y1 of x plus c2 y2 of x, and c1 e to the power minus 3x plus c2 e to the power 4x. So this is the general solution of the given differential equation. This is how we write the general solution. I hope you get it. If you have any question, you can ask me. There is a question in the chat window. Infinity is not included in real line, on real line, because we take the open interval. Okay, whenever you write R, the set of real number, you write it is as an open interval. Okay? Infinity or minus infinity is not included in this set, and we are talking about all values of x belongs to R. X should belongs to R. Infinity minus infinity, they are not included in R. So I hope you can write the general solution now. अगर हमारे पास if we are given third order differential equation, we must have three independent functions which forms the fundamental set, and then we can write the general solution using three constants C1, C2, C3. And this जी बेटा बोले
So y1 और y2 अगर वो फंडामेंटल सेट ऑफ सॉल्यूशंस ना फॉर्म करते, मतलब कि वो लीनियरली इंडिपेंडेंट ना होते, तो जनरल सॉल्यूशन फिर भी यही होती.
No, then technically we cannot write the general solution in this way because the functions are dependent on each other. ठीक है?
सिर्फ फंडामेंटल सेट के लिए हम लिख सकते हैं जनरल सॉल्यूशन.
Definitely. The functions should be linearly independent. ठीक है? If the functions are dependent on each other, यहाँ पे for example मैं y2 को e raised power 4x की जगह मैं 3 times e raised power minus 3x लिख दूं. Means y2 is dependent on y1. y2 can be written as a linear combination of y1. Then these two functions, they do not form the fundamental set. Then we cannot write the general solution in this way. Why? Because C2 depends on C1 in that case. Okay? They are not zero identically. In that case, Wronskian would be zero for some value of x. Okay? So if they are not linearly independent, then we cannot write the general solution of that particular homogeneous ODE. ठीक है? देखिए, I told you earlier as well कि किसी भी differential equation का जितना order होता है, उतने ही उसमें integration constants आने चाहिए. If you have a first order differential equation, in order to find the solution, you have to integrate it once. Then you must get one integration of integration constants. Okay. If you have second order differential equation, in order to get the solution, you have to integrate it somehow 2 times, okay, to get the solution. So you must have 2 integration constants in that case. If you have a third order differential equation, you should have 3 integration constants. So this is basically the same idea here. Okay, if you have a second order differential equation, which was the case in this example, you had a second order differential equation here. Its solution must contain two integration constants or 2 constants, you can say. Okay, so its general solution must contain 2 constants. जो कि यहाँ पे we had written here C1 and C2. अगर second order में के solution में 2 integration constant नहीं है, so there is some problem. That is not the general solution of the given second order ODE. अगर हम कहते हैं कि यहाँ पे सिर्फ एक constant है, we don't have this term here. Only this is the solution of this would definitely be the solution of the second order differential equation. ये solution होगा, but it is not the general solution. It is some kind of special solution, you can say. ठीक है? But this is not the general solution. The general solution must contain same number of constants as of the order of that differential equation. Homogeneous differential equation. ठीक है? Remember this. क्यों? क्योंकि if you have a second order initial value problem, then you have 2 initial conditions in that particular problem. अगर आपके पास for example आपके पास second order initial value problem है. Second order initial value problem क्या होगा? Second order initial value problem. Second order initial value problem को हम कैसे define करते हैं? A2 of x, y double dash plus A1 of x, y dash plus A naught of x, y equal to 0. Homogeneous की बात कर रहे हैं. Right hand side 0 होगी. अब आपके पास क्या बात कर रहा था मैं? I forgot. हाँ, इसको अगर आपके पास जनरल सॉल्यूशन फाइंड करना है आपने, इस डिफरेंशियल इक्वेशन के साथ हमें 2 इनिशियल कंडीशन गिवन होंगी जो कि y of x naught is y naught and y dash of x naught is y1, where y naught and y1 are some constants, and x naught is the initial value of the interval where the differential equation is defined. तो अब आपके पास दो इनिशियल कंडीशन है. इस डिफरेंशियल इक्वेशन में दो अननोन कांस्टेंट्स होंगे जो कि कांस्टेंट ऑफ इंटीग्रेशन हम मैथमेटिक्स में बेसिकली हम उनको ट्रीट करते हैं. उनको फाइंड करने के लिए आपके पास दो इनिशियल कंडीशन हैं. दोनों इनिशियल कंडीशंस को यूज करेंगे, वो दोनों इंटीग्रेशन कांस्टेंट्स की वैल्यूज फाइंड करेंगे एंड यू गेट सम पर्टिकुलर सॉल्यूशन. अगर आपके पास यहाँ पे ये सॉल्यूशन है जो कि जनरल सॉल्यूशन नहीं है, जिसमें एक कांस्टेंट है, तो एक कांस्टेंट आपके पास उसकी वैल्यू पहली इनिशियल कंडीशन से आ जाएगी, दूसरी वाली जो इनिशियल कंडीशन है वो रिडंडेंट होगी. ठीक है. सो दिस is not the general solution of the given ODE, but C1, C2 e raised power 4x, this is the general solution of the given second order ODE. Okay. I hope you get it. If you have any question.
Particular solution किस चीज की आप बात कर रहे थे, वो नहीं समझ आया.
Particular solution is the solution which is obtained from the general solution by choosing some particular values of C1 and C2. ठीक है.
तो वो तो कोई भी हो सकती हैं या फिर specific?
वो कोई भी हो सकती हैं. यहाँ पे C1 and C2 we can choose their any particular values. For example, 4 is e raised power 3x minus 9 e raised power 4x. This is basically a particular solution of the given differential equation. But C1 and C2, remember that C1 and C2, they are arbitrary constants. They belongs to R. They can take infinite many values. So you have infinite many solutions of a particular differential equation. यही तो हमने शुरू में we discussed it in the direction fields. Direction fields में how many curves of the solutions you can plot? Infinite many. If you have arbitrary constants in the solutions. Okay? If you have a general solution of a differential equation, you would have infinite many solutions of that differential equation due to the presence of these arbitrary constants. Okay? One particular solution from those infinite many solutions, you have to find that solution. That would be the unique solution, which these initial conditions help us to find those constants, the particular values of those constants, and we get the required solution, required particular solution of our problem. Okay? And how do we define these initial conditions? They are defined basically by looking at the physical problem, okay, which you are trying to solve. For example, if you are trying to solve a rocket is moving, or an aeroplane is moving, or a car is moving with an acceleration, you are trying to discuss its acceleration, then you have to put some initial conditions on the movement of that car. The car was initially at rest. Okay? Initially, the velocity of that car was 0. Initial conditions you know about some particular physical phenomena, and you can define the initial conditions on that problem, which suits that problems physically. Okay? So initial conditions, by looking at the physical phenomena or physical problem which you are trying to solve, you put initial conditions on that particular problem yourself, because you are basically the scientists which are trying to solve some physical process or some practical problem. ठीक है? जैसे कि population growth models में या logistic growth models में, I gave you an example of coronavirus. Coronavirus में initial condition क्या थी? One, the campus is basically isolated. There are 1,000 students and one infected student entered in that campus. Okay. Initial conditions क्या थी? At time 0, there was only one person who entered in the campus with infection, and that person started infected other students. So depending on the physical phenomena you are discussing, you put the initial conditions according to the situation. I hope you get it. Who asked me the question? I don't know.
Yes, sir. Thank
You got it, Fike?
Yes, sir.
Okay. Now, I hope you get all this discussion. If you have any question, you can ask me. Otherwise, we are going to uh, discuss reduction of order. Reduction of order. Method of reduction of order. आप ये कह सकते हैं. Method of reduction of order of an ODE. आप कह सकते हैं. Of an ODE, of a second order ODE. ठीक है. यहाँ पे आप कह सकते हैं of a second order Now, why this method is important and what is this method? This is our given differential equation, which is a general second order homogeneous linear ODE. ठीक है. अब यहाँ पे second order homogeneous भी लिख दें. Homogeneous linear ODE. This method is valid only for second order homogeneous linear ODE. Okay. What we do here, basically, we try to reduce the order of this differential equation. ये second order है, हम इसको order reduce करेंगे. We will transform this equation into a first order differential equation. Okay. Why we are doing this? Because we need okay. If we are given, if y1 of x is a solution, it is known, basically known, we know it. Y1 is a solution of the second order homogeneous linear ODE, which is given, which is written here, ODE1, आप इसको 1 कह दें, this equation is 1. अगर y1 solution है इसका, ठीक है, we know it, we already know it. We can find the second solution. Okay, we can find second solution of 1. Why we are trying to find second solution? Because we need to write the general solution of the given second order ODE. General solution के लिए आपके पास you must have two linearly independent solutions. एक solution अगर आपको पता है, तो we can find second solution. We can find the second solution y2 of x, which is linearly independent which is independent of y1 of x by using method of reduction of order. So this method is very important. This method will be used in while we discuss how to solve higher order ODEs. Okay. Higher order ODEs. So we can find if y1 is a non-solution, it is given. We can find the second solution y2 of x, which will definitely be independent of the first solution y1. Means both solutions y1 and y2 they forms a fundamental set of solution, and then we can write the general solution. Okay. By using this method of reduction of order. We know that अगर आपके पास y1 और y2 अगर they are linearly independent, if y1 of x and y2 of x are linearly independent, solutions, if they are linearly independent solutions, then they, or you can say their quotient must not be a constant. Okay. Must not be a constant. क्यों? क्योंकि अगर ये linearly dependent हैं, तो y2 will be some constant multiple of y1. ठीक है? अगर ये dependent है, अगर independent है, तो इनका जो quotient होगा वो constant नहीं होगा. Means y2 is not a linear combination of y1. Or you can say that y2 of x divided by y1 of x is some function u of x. ठीक है? अगर ये इसका quotient constant नहीं होगा, तो इन दोनों का quotient क्या होगा? Some function of x होगा. In that case, how can you write y2 of x is equal to u of x times y1 of x? This expression, we can use it, but remember that y1 is known. It is known function. y1 is known solution. Okay? It is a known function. We can use this expression to reduce the order of the given differential equation. Okay? How do we reduce? We need to find y2 as a solution of the given differential equation. We assume that अगर ये solution होगा, if this is the solution of the given second order differential equation, then we can insert this function into the second order differential equation. So इसको अगर हम differential equation में insert करें, तो आपके पास यहाँ पे we need to insert that function here. या आप इसको पहले standard form में लिख लें, that would be more easy to simplify things. ठीक है? If you have this kind of differential equation, you can write this differential equation in this way. We divide both sides by a2 of x. a2 of x से आप divide कर दें. ठीक है? y dash plus a naught of x divided by a2 of x, y equal to 0. Now this becomes y double dash. Remember that its coefficient is 1. Its coefficient should be 1 plus p of x y dash plus q of x y equal to 0. Where I hope you know p of x is what? a1 of x divided by a2 of x, and q of x is a naught of x divided by a2 of x. This is basically, you can say, the normal form or a standard form. What do we say it? Standard form is in standard form. ठीक है? इसको आप equation 2 कह दें. ठीक है? Now we need to insert this transformation. It's basically a transformation which will convert this equation 2 into this will transform this equation into a differential equation of order 1. इसका order क्या है? 2 है. So if we use that transformation y2 of x equal to u of x into y1 of x, if we use this transformation into this differential equation, which is the second order differential equation, that transformation will transform this equation into a first order differential equation. Okay. First order differential equation में convert कर देगी, and then we solve that first order differential equation and get the solution y2. We'll discuss this in the next lecture. Okay. For today, I think it's enough. If you have any question, you can ask me.
सर एग्जाम्स में MCQ